So the given question is, a wire has resistance 12 ohm. It is bent in the form of a circle. The effective resistance between two diametrically opposite points of the circle is. So this question came in 2016. It is a numerical question. So first of all, you have to know what diametrically opposite points mean. So as you have already seen that this question pertains to a circle, so if we draw a circle like this, diametrically opposite points means those points which lie on the opposite sides of a diameter. So it may be any diameter. Let us suppose this is this diameter for our example. So we are talking of this point and this point. Let us call this point as A and this point as B. So for convenience, let me just rub off this diameter. Now the total resistance is given as 12 ohms. So naturally you must have guessed by now that the resistance of the two sections are 6 ohm and 6 ohm. So if we redraw this figure, we will get something like this. So here we have our point B and here we have our points A, and instead of drawing a semicircle, I can simply draw a resistance in their place. So my problem has been reduced to a very simple form. Now if I want to find the effective resistance between two diametrically opposite points, I have to see if some current flows through this point. Does the same current flow through the two resistances? The answer is no, because the current gets divided here at the point B, and some amount of current flows through the upper resistance and another current flows through the lower resistance. You can imagine the flow of current to be the same as the flow of liquid in a pipe. If you have a pipe which is in this form and which gets divided like so, and if a stream of water is flowing like this, naturally at this point the water will get divided into these two segments of the pipe. In the same way, the current at point B also gets divided in two parts. This type of flow is called a parallel combination of resistances, where different current flow through different resistances. So this is a very easy way to recognize which is parallel resistance, which are parallel resistances, and which are series resistances. For resistances in series, you have the same current flowing through the two resistances. For example, if this is R1 and this is R2, you have the same current flowing through R1 as well as R2, because there is no other way or path for the current to leak out of this circuit. So now you must have already guessed how to solve this problem, because these two resistances are in parallel. So we'll apply the formula of parallel resistances. So 1 by R equivalent is equal to 1 by R1 plus 1 by R2, which is equal to 1 by 6 plus 1 by 6. The LCM is 6, and 1 plus 1 is equal to 2 by 6, which is equal to 1 by 3. Now remember, in the left hand side you have got 1 by R equivalent. So if you take the reciprocal on both sides, what you will get is R equivalent is equal to 3. So the given answer is 3. So let me show you a trick to solve quickly when resistances are given in parallel. If there are two resistances, you can simply apply the formula R equivalent, or you can write R parallel is equal to R1 times R2 divided by R1 plus R2. Now if you plug in the values here, you'll see that the upper the numerator becomes 6 ohm times 6 ohms, and the denominator becomes 6 ohm plus 6 ohm. So you can simply solve this, or you can just take out a 6 common from here, or whichever way you like. So let me just make this simple. This is 6 times 6, and ohm into ohm will give you ohm square, and here 6 plus 6, this is ohm. So 1 ohm will get cancelled with another ohm, and you'll be left with only one single ohm. If you take a 6 common, you'll get 1 plus 1 2, and here you get 6 into 6, you cut 1 6 with the other 6, so you'll get 6 by 2 ohm, which is equal to 3 ohm. This is just a way in which I have done. You can do it in any way you like, you'll get the same answer. For example, you can simply do 36 ohm divided by 12 ohm also from here, which will give you 12 3s are 36, and this ohm will get cancelled with 1 ohm in the numerator, and you'll end up with 3 ohm. So the correct answer will be D, 3 ohm. You could have simply guessed the answer to this problem without even solving the problem. For that, you have to know that the equivalent resistance, when the resistances are connected in parallel, is always less than the smallest of the two resistances. For example, the two given resistances here are 6 ohm and 6 ohm. So your parallel equivalent parallel resistance will be less than 6 ohm. So if you look at your options, you will see that 12 is greater than 6, so this is not going to be the correct option. 24 is also greater than 6. 6 is equal to 6, so this is also not the correct answer. So you are left with only one answer, which is less than 6, and that is 3 ohm. So this will be your correct answer. So in this way you can solve this problem without actually performing the calculations.